So now let's go ahead and look at some examples. Number one, an academic counselor claims that students take the same number of units regardless of their year in school. Test this claim at the alpha equals 0.05 level using the data below collected from the same class. So because this problem states the same number of units, that means H naught will be our claim. So here is our table, and we're ready to find or state H naught and H1. H naught always begins with the number of means are equal, which we said is our claim. There was 1, 2, 3 different groups of data. So we have 1, 2, 3 means listed for this problem. And H1 is always the statement, at least one mean is different. So now we're ready to find the critical value. First, we find the degrees of freedom for the numerator of the F-test. We don't need to know what the numerator is. We know that the degrees of freedom for the numerator is calculated by the number of groups minus 1. We just said there is 1, 2, 3, or maybe you could just kind of always look at what's that last subscript. And so we're going to have 3 minus 1, or 2, for the degrees of freedom for the numerator, which tells us we're going to be in column 2. Next, we need to find the degrees of freedom for the denominator, and the formula for this is the total count minus the number of groups. So that means we need to come over here and say 4 plus 2 plus 3. We don't need to add the actual values, just how many items per group, and 4 plus 2 plus 3 is 9, minus the number of groups. Remember, the number of groups was 3, not 2. Watch out for that. And so we're going to be in degrees of freedom, or row 6. So finding where these numbers meet lets me know that the critical value is, we had to be on table 0.05. The critical value is 5.14. So now we're ready to find the test statistic. Before we can do that, we need to collect some information. First, we need the sum of values for the first group. So I need to add up 14 plus 15 plus 11 plus 16 to get 56. I need to add the numbers from the second group to get 26. Didn't even need a calculator for that. Notice I'm writing these numbers on the same row. Even though I have space to write the sum up here, I've accidentally taken wrong numbers and grouped them together because they were side by side, even though they weren't like terms. So I prefer to write everything in a row straight across. And now I need the sum of numbers from the last row, which again doesn't even need a calculator to get 39. Next, we want the count of items per group. We'd previously done this, but I want it listed here. I can see there are 4 numbers in the first group. In the second group, there are 2 numbers, and in the third group, there are 3 numbers. Now I need to find the average from group 1. That's actually just 56 divided by 4, which is 14. Or, because we're going to need the variance in a few minutes, perhaps you've already entered all of the numbers from group 1 into your calculator and just taken the X bar off of the output numbers. The average for group 2, dividing 26 by 2, we're using my calculator, output of 13. And for group 3, it happens to also be 13. I have 2 means that are the same. Now, 14 is obviously different, but is it statistically different enough? And that's what the ANOVA test is going to tell us. The final thing is my calculator will only give me the standard deviation from group 1, but remember, I'm going to need to square that answer. And in this case, I get 4.6666. It goes off the edge of the calculator, so we'll address those decimals in a minute. The standard deviation from group 2 is going to need to be squared. So I have the variance from group 2, and my calculator showed me that this is 18. And the group 3 standard deviation squared to give me a variance is just 3. Now, kind of some big jumps here, but the ANOVA test is going to let me know more about that. I'm ready to find X bar GM, the grand mean. So I need to take the sum of all of these numbers, but you'll notice I didn't start with that. We've already been adding them by group. I think it's easier to start with that 56 plus the 26 plus the 39 and divide that by the count. Again, we know the count is 9 from the previous work, but we could say I'm going to take the count by how many items are in the first group, which is 4, sorry. The count of items in the second group, which is 2, and the count of items in the third group, which is 3. It's a little confusing that the second group had a count of 2 and the third group had a count of 3. So we're looking at 121 divided by 9. And so we have a grand mean of 13.444. Let's see, my smallest number is 11. My largest number is 16. Yeah, my means in there seems reasonable enough. Now I need to find the variance between the means. So the formula for this is I'm going to add up the count of items from each group times their group average, but I'm kind of taking an average of these or a variance of these. So I need to subtract that grand mean value. And because subtractions can give you negative numbers and we're summing these up, we're going to go ahead and square those subtractions before we multiply them with the group count and then divide by k minus 1. So this is what it looks like. I'm going to start with the count of items from the first group, which is 4. I need to multiply that times the group average, which in group 1 is 14. And now I need to subtract that grand mean, which in our case is 13.444. Remember, I'm just going to go one digit past what I need to answer in the question. I'm going to square that, and I'm just going to work on the numerator right now. So the next thing I do is move to the next group, where I start with what was the count of the next group, which is 2. I need to multiply it with their group average of 13, and I need to subtract the grand mean, which we just stated previously as 13.444, square this, and complete the process for the third group, whose average is 13, subtracting that same grand mean and squaring. So I have the numerator written out. Now I need to divide by k minus 1. Remember that k is the number of groups, and we can see there are 3 groups. I find it's easier sometimes to just calculate a value for the numerator and then divide by 2, which I can just do the subtraction. Otherwise, you end up with a lot of parentheses trying to enter this all in at once. And I get 1.111. It's kind of hard to tell what this would look like visually if my number's on track. Now I'm ready to find the other variance. This is the variance within the means. And this formula has you add up the count of each row minus 1. Maybe think degrees of freedom or standard deviation formulas. And I'm multiplying it by the variance for that group. So keep in mind in this case that we're not squaring anything. We had to square in our formula for the between means variance, but we have an already squared item here. And this formula is divided by the count or sum of each of those counts minus 1. So we start with our first count. There were 4 items in the first group of data, and their variance was the 4.667 because I'm rounding. Moving to the next group, I need to take that 2 minus 1. Are you really writing that though? You could have just written a 1 and multiplied times the variance of group 2. And then when I move on to group 3, you're probably just putting a 2 because I just did 3 minus 1 and multiplied by their variance of 3. And the whole thing is divided by each of those subtractions of counts that we just did. So 3 from 4 minus 1, and then the plus 1 and plus 2. So we're looking at 38.01 divided by 6, which is 6.3335. So now we're ready to find our F test. Remember, this is the ratio of the variance between means divided by the variance within the means. So we need to take our between mean variance, which we're writing as 1.111. Okay, yes, we're in trouble. We just used a rounded number calculated from rounded numbers, but turns out we're going to be fine in terms of accuracy. We need to divide by the within mean variance. So divide by the 6.334 with rounding. And my F value is 0.1754, which is my test statistic. So rounding this to 2 digits, that 7's going to round up because of the 5 following it, and my test statistic is 0.18. Now we're ready to decide if we reject or fail to reject H naught. So I'm a visual person. I got to draw my right skewed curve because that's what we use for an F test. But the key is you have a number line starting at 0. My first value on a number line would be 0.18, which is my test statistic. My next value is the 5.14, which would be to the right of that, is my critical value. Now remember, because I said it's always a right-tailed test, that means I shade to the right of the critical value. So when shading to the right of the critical value, I see that my test statistic does not fall in the shaded region, so I do not reject it. I failed to reject H naught. For my final conclusion, I look back and I wrote that the claim was H naught. We just decided that we failed to reject H naught, and so my guidelines tell me to start with, there is not sufficient evidence to warrant rejection of the claim that, taking it from this question, students take the same number of units regardless of their year in school.